In this video, I'm going to explain problem 2 in section 4. The first thing I've done here is I've loaded our data points into Microsoft Excel so I can get a nice easy graph so I don't have to try and do this by myself. And I just realized that that is 2, 6, 6, 4, 5. All right, so the first thing I'm going to do is I'm going to create a scatter plot. So I'm going to select this data. I'm going to go to Insert. I'm going to go to Scatter, and now I have a graph. Now, this graph needs axis titles and an actual title, but for the sake of the explanation, I'm not going to go through that. So the first question is, graph the data. Is it linear? Well, it looks linear to me, and it is linear because here we have a constant change between our x values and a constant change in our y values. That constant change is about 4,615. No, it's not about. It's... So, if I wanted to find the slope, which is the second question, okay, it's actually saying, what is the visual estimate of the y-intercept? In order to do that, we need our slope. So to figure out our slope, that is m equals, we know that the x value goes up by 500, and our y value, we can figure that out. We can figure out the constant change there. So I'm going to call up the calculator and figure that out. And that's 4,615. So our slope is 4,615 divided by 500. That equals 9.23. Okay, so our slope is 9.23. We can plot all those points and go down by a factor of 9.23 every time until we get to the y-intercept. Or we can look at this, and I'm going to copy and paste this. Copy. I'm going to paste, whoops, sorry. I'm going to paste this in Paint. And I can draw a line from this point to the x-axis, and that to me looks like it's about 13,000. Okay, so my visual estimate is about 13,000, but I can find the actual intercept. I already know what my slope is. I'm going to make this a little bigger. I know what my slope is. I know my slope is 9.23. And this is going to help us with our third question because it's asking us what the, let me actually get to the question. It says graph C of x on the data from part A. Well, I did that. I drew the line. Okay, so I graphed the data, I came up with a visual intercept, and I've graphed the line. Now I need to find the equation for C of x, so this is part D. Okay, so I know my slope is 9.23. I have points available. Okay, I have points 500, 1,000, 1,500, and 2,000, and my cost points. So I'm just going to use 1,000 and 22,030 for my points to build my equation. So I know that my linear equation is y equals mx plus b, right? So I need to find what my b is. Well, I know my y value is 22,030. I know my m is 9.23. I know that my x is 1,000. And I don't know what my b is, so I can go ahead and solve for b. So this is 22,030 equals, I want to show you the steps, but I only have 30 seconds. So this is 9,230 plus b. B equals 12,800. So stay tuned for part 2. Alright, so when I last left you, we had just figured out our y-intercept. Now I need to take all of this information. I need to take my m and my b and put it in an equation. So we're going to take y equals mx plus b again. And I'm going to leave my y alone because that's a variable. My m is 9.23. My x is going to be left alone, plus 12,800. So this is actually c of x. Now, the question is, what is the fixed cost and what is the variable cost? Well, we know the fixed cost is the 12,800, and we know that the variable cost is $9.23 a unit. Now, we want to find the equations for r of x and p of x. Well, r of x is the revenue, so I'm going to do r of x in blue. R of x is the revenue, and we know that that is the unit price, not cost to the consumer, but price you sell it at, times number of units. So what I can do here is I can say that in our problem, the selling price is $12.25. So R of X is just equal to 12.25 X. Okay? So revenue starts at 0. We always know revenue starts at 0. Now we want to find the profit of X. The profit of X is your cost, or sorry, is your revenue minus your cost. So now what I need to do, and I'm going to move up a little bit so I have some room, and I want to change that color. Sorry. All right, so our profit is equal to our revenue minus our cost. So my revenue function minus our cost function and I want that in green, 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 green. So that becomes, whoops, 12.25 minus 9.23 is 3.02. So we make $3.02 per unit. But we always have to take into account our fixed cost. So our profit function is 3.02x minus 12,800. So now what it's asking for is our break-even point. Our break-even point always comes when our revenue equals our cost. I'm going to change colors. I'm going to go back to black. Okay? Or when our profit function equals 0. There are several ways that you can get to the break-even point, but I'm going to save that for another video. So stay tuned for part 3. So, right, break-even point. Revenue equals cost or profit equals 0. I like setting revenue and cost equal to each other and solving for x, but other professors, and however you want to do it, whatever's easier for you, you can do, think that it's easier to set profit of x equal to 0. So I'm going to set profit of x equal to 0 and solve for x. So that becomes 3.02x equals 12,800. X equals 4,238.14. Now, can I have 0.14 of a unit? No, I can't, so my break-even point is actually going to be 4,239 units. Okay? So now we have our break-even point. Now I want to graph P of X, R of X, and C of X on the same axis. Graph and label the same intersection point. Now I had made a picture and I had posted it on the discussion forums, but I'm going to copy that picture here because I hope to use this video in future classes, so I'm going to just include it in the video. So I'm going to pause this video for a moment and get my axes laid out. Alright, so I've took the picture off the Blackboard website because I'm on a different computer than the one I generated this one on. So the blue line here is your profit function. And when it crosses the x-axis, that's your break-even point. When profit is equal to 0, where you're not in the negative anymore and you're just going to see positive gains from now on. The intersection point is where revenue and cost meet, which is parallel to the break-even point. The break-even point's on the x-axis because that is representing how many units you need to produce. The intersection point is higher up on the y-axis because not only is it units produced, but it's money generated. So when you're graphing P of X, R of X, and C of X on the same axis, it will sort of look like this. Graphing and labeling the intersection point is this purple point right here. So I'm going to pause this and put some data into Excel, and then I'm going to show you how to do it in Excel. Actually, I'm going to let you see the step-by-step process. So I'm going to make a column for revenue, and I'm going to make a column for profit. Now, revenue, I know that my equation, let me call it my revenue equation, is 12.25x for how many units sold. So I'm going to type in equals. The equal sign tells Excel that it's ready to do math. 12.25 times my x value, which is my units. And I'm going to drag and drop this down. So that's my revenue for every unit sold. And on my profit, I'm going to say equals. I know what my profit equation is. I know my profit is 3.02 times 3.02 times my x value minus my 12,800. And I'm going to drag and drop that. Okay. Now, to graph this all on the same axis, I'm going to select all the data. I'm going to go to Insert. You can't see the Insert part because I have the capture all wonky. Hold on. There we go. So I go to Insert, Scatter, and this is all weird. So Series 1. This is my x values. This is not my x values. This is not working. So switch rows and column. There we go. So much nicer three graphs on Excel. However, you don't see the intersection point, so you're going to have to extend those lines out and then graph that extension point. You can do that by adding more x values. Hopefully that is helpful. Hopefully that'll get you through this section's homework now. If not, keep emailing me.